Okay, everybody, I thought I'd work through a few of these kinds of problems where we're using a balanced equation and information about one molecule to make predictions about another molecule. These are called stoichiometry problems, and this is the kind of problem that most of the class got wrong on the quiz on Wednesday. So 4 of these problems will be posted for our activity for today, and I'll work through 4 of them. And the other 4 you should be able to solve by analogy because I've just put 4 very similar problems right after the ones that I'm going to work out. These will also be the problems on your, or 4 of the problems on your quiz today. All right, so for example, here I've got photosynthesis. Carbon dioxide combines with water to make oxygen and glucose. So suppose we have 37.8 grams of carbon dioxide coming in. What mass of glucose will come out the other side? So we need to use the mole ratio at the center of the problem. That's our connection between the carbon dioxide to the glucose. It's a 6-to-1 ratio is our conversion factor. So we're given a mass, but we need to work in moles. So 37.8 grams of carbon dioxide. I'll convert to moles carbon dioxide, and the molar mass I got from the periodic table. So carbon plus 2 times oxygen is 12.01 plus 2 times 16 gives you 44.01 grams carbon dioxide. Then 1 mole of glucose for 6 moles of carbon dioxide. And then I can get the mass of this, again using the periodic table, 6 times carbon, 12 times hydrogen, 6 times oxygen, that's 180.156 grams of glucose per mole of glucose. Moles glucose cancel, moles carbon dioxide cancel, grams carbon dioxide cancel, and you get grams of glucose, 25.8 grams glucose. 1b will be very similar, except now you're burning natural gas, and you're going to figure out how much water is produced in that reaction. Don't forget the 2-to-1 ratio at the center of the problem. All right. We can also do, this is a simpler problem where we're just going from moles to moles. So here I have a balanced reaction for rusting of iron. And how many moles of rust are formed from rusting of 5 moles of iron? So we're already at moles. So we don't need the molar mass because we already know it's a 4-to-2 ratio in moles. So just take your 5 moles of iron, multiply by 2 moles of rust for every 4 moles of iron, and you get 2.5 moles of rust, or iron 3 oxide. See if you can do this similar problem that involves baking soda falling apart. All right, and then number 3, mass of reactant to atoms of another reactant. So here we're going from mass of a reactant, and we'll use Avogadro's number to get the number of atoms of another reactant. So for example, 32 grams of sulfur dioxide. This will come out of power plants and will interact with oxygen in the air and humidity in the air to make sulfuric acid, and that's the main component in acid rain. All right, so 32.0 grams of sulfur dioxide. Again, get the molar mass from the periodic table. Grams cancel, and you have moles sulfur dioxide. And then it's a 1-to-2 ratio to get moles oxygen. And then in this case, the problem is asking for us for how many molecules, and we know it's 6.022 times 10 to the 23rd, Avogadro's number of molecules per mole. So then you end up with a number of molecules. It's a big number because there's a lot of molecules in a macroscopic amount of material. Should be able to do the same kind of thing, but with 32 grams of nitrogen dioxide. And this is going to be a 4-to-1 ratio instead of my 2-to-1 ratio that I had. All right, one more problem. This time we're finding an amount of leftover reactant, given initial masses of both reactants. So here I've got nitrogen combining with hydrogen to make ammonia. And I know that I have 10 grams of nitrogen, 5 grams of hydrogen, and I want to know how much hydrogen will be left over. Okay, so go away. Anyway, there we go. So to get how much is left over of anything, this applies just to life in general, you need to know how much you initially had and then subtract how much you used. So we know how much we initially have of the hydrogen. It's 5 grams. We need to find out how much we use and subtract from the 5 grams to figure out how much we have left over. So how much do we use? Well, we know that we react the whole 10 grams of nitrogen. That reacts completely. So 10 grams of nitrogen, convert to moles, use the 3-to-1 ratio to get moles of hydrogen, and then multiply by the molar mass of hydrogen, and that's how many grams of hydrogen you used. Good. So are we done with the problem? No. Remember, we want to get what's left over, so initial minus used. So the leftover H2 will be the initial was 5 grams minus 2.16 grams used gives 2.8 grams left over. And you should be able to do the same thing with 4B. All right, that's it for today. Have a good weekend.